Okay, so we have to sketch the solution curve, and it passes through 0, 2, which is right here, and through the point 1, 0, which is right here. Well, I see at 0, 2, look at all these slopes. All of them are horizontal. So then what that means is we're going to, if it has to pass through 0, 2, we're going to have a horizontal line that goes through 0, 2, like that. Now, let's take a look at 1, 0. Okay, 1, 0 is a different story. You see how these slopes kind of, they go up like this, and it seems like they branch out a little bit this way. So my thought is this would be an asymptote, and my graph is going toward that and then branching out. And look, the same thing happens on the other side over here as well. And then if we look below 1, 0, it kind of looks like it comes down sort of like parabola-ish, so to speak. So I'm going to draw that, and I would say, oops, I should put my pen on maybe. Roughly, it's going to go like this, come back up, and like that. Ooh, that was bad, but kind of like that. Okay, there's part A. All right, so part B says to write oops, oh my goodness, write an equation for the line tangent to the graph. So we know what that means. I hope you know what that means at this point. So we've got y minus y1 equals m times x minus x1. And they were so nice to you, they actually gave you that point. So then we know that we've got y minus 0 equals m times x minus 1. Okay, well, m is slope, right? Isn't that the slope? So then all we really have to do is take that slope, and we are going to evaluate that at the point they gave us, which was 1, 0. All right, so we've got 1/3, and the x value is 1, so that's 1/3 times 1, so I'm just going to leave that as 1/3, parentheses, and the y value was 0 minus 2, and that quantity squared. So that would be 1/3 times 4, which is 4/3. Okay, so y equals 4/3 times x minus 1. Okay, so there is the equation of the tangent line. Now they also say, last sentence, use your equation to approximate f of 0.7. So f of 0.7 will be approximately 4/3, and then we're going to put in 0.7 minus 1, which we know is negative 0.3, right? So we have 4/3 times negative 0.3. Now you can leave your answer like this if you want to. There's no need to calculate it any further, or you can be a little crazy like me, and I'm going to keep going. So that ends up being negative 0.4. But again, either one of these would be fine. All right, part C says find the particular solution, and hopefully at this point you know that means to cross multiply and separate the variables. So I'm going to get 3 dy equals x dx times y minus 2, that quantity squared. Okay, so I'm going to divide out that y minus 2 quantity squared, but at the same time I don't want that 3 over there on the left hand side either. So I'm going to divide out that 3. The more I can get that y stuff by itself, the better off I'm going to be. Okay, so then that leaves me with dy over y minus 2, that quantity squared. And then over here, I'm going to have, what's that going to be, 1/3 x dx. Okay, now I hope you see something over here, because I have a quantity and it's squared, right? That means I'm going to have to do u substitution. So my u is going to be y minus 2, and then my du is going to be just 1 dy. So I don't need anything. So when I integrate over here on the left-hand side, this is really going to be the integral of du over u squared. And I'm going to take that u squared and I'm going to bring that up and make that u to the negative second power, if that's good with you. Okay, so then I have the integral of u to the negative second power du. And then on the right side, I have the integral of 1/3 x dx. Okay, so on the left-hand side, I'm going to get negative u to the negative first, which is negative 1 over u, equals, and then on the right-hand side, I'm going to get x squared. Now technically divided by 2, but I already have a 1/3 there, so that's going to make that 1/6 plus c. Okay. All right, so you can see all I did here was I changed my u to its value, which is y minus 2. All right, now from here, I would probably suggest that you plug back in the value that they gave you originally, which was 1, 0, so we can find our c. And I'm going to continue that on the next slide. All right, so if I plug in 0 for y, on the left-hand side, I am going to get a positive 1/2 equals, and then on the right-hand side here, I'm going to get 1/6 plus c. All right, so then you're going to work that out, get your common denominator, stop me for a second, figure out what c is. All right, I have 1/3 for c. So I'm going back to the original equation that I had on the previous slide, which was negative 1 over y minus 2 equals 1/6 x squared. And now we know what c is, so I'm going to add that in. All right, so now we're going to try to get y by itself. Well, I'm going to get rid of the negative first. So that's going to be 1 over y minus 2 equals, and that's going to be negative 1/6 x squared minus 1/3. Okay, now, we did this in a previous problem as well. I don't like the fact that the y is in the denominator, so I'm going to flip this, and I'm going to flip this as well, and I'll show you how we do that again, just in case you forgot. So I'm going to turn this into regular y minus 2. And then what I do is just take that right-hand side and just put it all over 1. Well, put 1 over it, I should say. Okay? It's ugly, but it's right. Okay, and the last thing we have to do is get rid of that minus 2, which would be to add it, right? And this is going to make the answer look even uglier. But no big deal, just as long as we're right, that's all that matters. So plus 2. And there's your answer.